All right. So basically what I've done here in section 1 through 1-3, every section had some problem solving in it. I just decided to throw them all together and just do one problem solving unit here towards the end of the chapter. So basically I just pulled all of the different problem solving type problems from these 3 sections and put them all together. So you will be able to use the linear equations that we've been solving. You'll now be writing those equations and using them to solve real life problems. That's our objective. Okay. So our 4-step approach to problem solving. Okay. So this 4-step approach to problem solving, number 1, first you have to understand the problem. Figure out what it's asking you. What is the problem asking? Okay. So a lot of times that involves knowing what is the unknown. What is the stuff that we don't know? Okay. So what is the unknown? And many times now that we know how to solve equations, once we figure out what that unknown is, we're going to set it equal to, once we know that unknown, we're going to let a variable equal the unknown. Let a variable equal the unknown. Okay? And so part of understanding the problem is, what don't you know? What do you know? What is the given information? Look for that given info. What information do they give you? And not all the information they give you is going to be important. Okay? So it's identifying what's important and what's not in that problem and what's being asked. Okay. Step 2, make a plan. Okay. So make a plan on how you're going to solve it. We're going to look at a bunch of problem solving strategies. For a lot of this, look at the strategy list. That'll come next. We'll show you that strategy list. Look at the strategy list. Figure out if one of them might be a good fit for this problem. Okay. Look at the strategy list and decide which one might fit. There might be multiple ones that fit, and what you used might be different than what somebody else used. Okay? So look at the strategy list and pick one. Pick one that fits. Pick one of them that fits the problem. And don't be afraid to try another one if the one you picked didn't work. Try another if it doesn't work. This is what we call perseverance. Many of us are very perseverant when it comes to other things. Meaning, you want to go to the movies with your friends on Friday and your mom says no. You persevere. You find another way to go to the movies that Friday. Okay, well, can I go if my brother takes me? Okay, what if you drop me off? Or what if you find other ways around the problem, right? If the first thing doesn't work, you keep trying, right? Not many of us, the very first time we try to shoot a free throw, miss the very first one, be like, oh, no, I'm just not ever going to shoot a free throw. What do? You persevere. You keep trying. This is what we call perseverance. So if your first plan doesn't work, go back, pick a different one. Pick something else. Try something else. It's perseverance. Okay. Next, solve the problem. This is actually carry out the plan. Carry out the plan. Actually do what you said you were going to do in step 2. Be like, okay, in step 2, this is what I think I'm going to do. Carry out the plan. Check each step along the way. Check each step along the way. So carry out the plan and check each step along the way. So dealing with the first thing, be like, okay, did that make sense? Does that seem to be getting me to where I want to get? And the last one, look back. This is always my last. Does it make sense? Okay, it wasn't that long, and this to me is the most obvious, is people coming up with an answer that makes absolutely no sense. And be like, yep, that's my answer, circling it and moving on. Okay? Nothing frustrates me more than a question that's asking how many cupcakes should I bake? And they tell me negative 4,672. Be like, does that answer make sense? If I'm asking how many cupcakes should I bake? Makes no sense whatsoever. Okay? It wasn't that long ago, actually it was only a couple days ago, that somebody was asked, they wrote an equation, and they said, okay, if I have a 38 centimeter long femur, what's the femur? You know what your femur is? Yeah, it's like the bone in your leg. Okay, it's like that big bone in your leg. And it said, okay, so if somebody's femur is 38 centimeters long, how tall are they? And guess what the answer was? 2.7 centimeters. Does that answer make any sense? Their femur is 38 centimeters long. They're this tall. Okay. Made no sense whatsoever. They circled it and handed it in as it was done. And I'm like, well, you should have got to that point and realized, hey, wait a second. That doesn't make any sense. I need to go back and fix something. Okay? That's looking back at the problem and answering, did I answer the question that was asked? Not only does it make sense, but going back to step one, understanding the problem, did I answer what they wanted me to answer? Did I answer the problem completely? I'm going to look back. Okay. Any questions on our 4-step plan? Okay, so I can give you the next 4 steps and be like, okay, that's fine and awesome. How in the heck, what does that look like in an actual problem? Okay. All right, but first we need to talk about some problem-solving strategies. 1, use a verbal model. This one's probably This one's probably my favorite, using a verbal model, because so often you guys are really good at telling me, like you can say in words what to do, or, well, I would have to take how tall she is now, subtract how tall she was to figure out how much she's grown. You can tell me that. We'll write that down in words. And then replace those words with our mathematical symbols, subtract, equal sign. Okay? So that verbal model, so this uses words. So basically you use words and then replace the words with math symbols. Use words, but then replace with symbols. What do I mean by math symbols? Replace with symbols, if you can. Yeah, add, subtract, multiply, divide, equal signs. And this using a verbal model a lot of times leads itself really well into writing that equation. Because once you have that verbal model written, once you have it kind of written in words, what you would do, once you replace it with those symbols, it turns into an equation. One thing, when you write an equation, you need to define the variable. What does it mean to define something? I've asked you to define parallel. What am I wanting you to do? Abby. Figure out what parallel is, right? Tell me the definition. Yeah. Yeah. Okay, 2 straight lines, yeah. So tell me the definition. I asked you to define cow. You have to define for me what a cow is, right? Which that's actually a hard one to define. We all know what it is, but could you actually write me out a definition? A big animal that we eat, milk comes from it. Okay, so you want to define the variable, meaning if you used X in the problem, what is X standing for? Is X standing for the number of cats? Is X standing for how much she grew? What is X standing for? And I'll show you what that looks like in a problem. Define the variable. Draw a diagram. That's extremely useful if there's a picture involved. Obviously, if you're talking about a rectangle or a triangle, draw a rectangle or a triangle. Okay. Drawing a diagram. Look for a pattern. Another one that's sometimes nice is that working backwards. Working backwards. Start at the end, what the end result is, and work your way backwards to what the beginning was. Okay. Guess, check, and revise. This one I would have to say is probably the least efficient. What do I mean by that? Least efficient. What does efficient mean?
It doesn't work as well?
It works, but it might not be the quickest way to get there. Okay, meaning efficient is getting there quickly with the least amount of work. So a lot of times guess and check is our default, but it's not always the most efficient. Along the lines of guess and check is making a table. That's a more organized guess and check way. I like to say making a table or a list is organized guessing and checking. Okay, you actually have a table and you put them in and see where it's up. Another one that I use all the time, break the problem into parts. Break it up into an easier problem or into pieces and solve each piece and put it all together. Sketching a graph or a number line is extremely useful as well. So if we ever get stuck on a word problem, come back to this strategy list, problem-solving strategies, and look, will any of these work for that? Because you may have forgotten one. Be like, oh, I could draw a number line for this one. Okay. And we'll learn some new methods. We're actually going to use a new method that's called a bar model or a tape diagram is what some people call it. A bar model or tape diagram, that's extremely useful when dealing with fractions. And we'll look at that later on. Okay. All right. Let's actually go ahead and do a problem. This should be the first example you see. Okay. Sorry it's so tiny again, it won't let me zoom in. I can zoom in on here, but it doesn't zoom up there. Okay, in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. Okay, so first step one, understand the problem. What are we trying to find here?
His average speed.
We're trying to find his average speed. So I'm actually going to mark it here. We want to find his average speed. I'm just going to kind of underline right there. Find his average speed. That's what we're trying to figure out, right? His speed. Okay. What information do they give us in this problem? 200-meter dash. Yeah, we have a 200-meter dash. What is that, 200-meter dash? Is that a race? What does that 200 meters tell us? How far he ran, the distance. How far he ran, the distance. So I'm just going to label in my problem, this is a distance. So they gave us a distance, how far he ran. What else did they give us? Time. Go ahead and write that too. We're just going to block. This is the time. And we're trying to find his average speed. Does anyone remember how distance and time relate to speed? From science?